Hello, Algebra 2 students, and welcome back. We are about to start a new unit today, Unit 4, about quadratic functions. And before we get started, I do just want to warn you that as we move into this unit, we are officially done with the easy part of Algebra 2. Starting with this unit, this course is going to start getting a little bit more difficult. Now, I don't mean to scare you with this. As long as you continue to stay on top of the work, as long as when you're watching videos, you're taking careful notes and thinking through everything I'm saying, as long as you continue doing the homework and continue putting in a good faith effort to all that, you're going to be just fine. Because this unit tends to start getting a little bit more difficult, this is usually, from what I've seen in the past, where people start to put a little bit less effort into this class, and it suddenly starts showing dramatically on tests and quizzes and all those things. Keep working, and you're going to be just fine. And please do keep working, and everything's going to be good. We are going to start on page 3 of this packet, and start looking at section 4.1 about quadratic functions in vertex form. But before we start getting into that whole vertex form thing, we need a definition of a quadratic function. I think I gave you this definition in the last unit when we talked about quadratic expressions and quadratic equations. But now we'll start moving into those functions, and we're going to say that a quadratic function is just a function in the form, y equals a x squared plus or minus bx plus or minus c. We saw equations in this form, ax squared plus or minus bx plus or minus c equals 0. We saw expressions where it didn't equal anything, but because it equals y, we now call this a function, which means we get something that we can graph. And I'd assume you probably remember from Algebra 1 the shape of this graph, and if you don't, well, you can just look directly below here, and you see that when we graph these things, we get parabolas. The graph, oh, looks like my pen is running out. Let me get a better pen. The graph is a parabola. This entire unit will be about graphing parabolas and understanding the graph of a parabola, and then we'll end with some applications. Why do we actually care about parabolas? And actually, there's all sorts of interesting things in the real world that can be modeled with parabolas. But before we start getting into a lot of nitty-gritty detail, we need to talk about some important parts of a parabola. First of all, the lowest point, or in some cases the highest point on our parabola, is called the vertex. This point right over here is called the vertex. And in this first example, the vertex has coordinates -2, -3. The vertex is either the lowest point for a parabola that looks like this, or the highest point for a parabola that looks like that. One thing about parabolas is they are symmetric, and they have what we call an axis of symmetry, which is going to be a vertical line that goes through the vertex. I'm going to go draw in a vertical line. Actually, I'm going to use a different color over here. I'm going to draw in a vertical line that passes through my vertex. And my parabola is symmetric about that line. If you fold the parabola over that line, this point will get matched up with this one, and this one will get matched up with that one, and everything's going to sort of match. That vertical line is called our axis of symmetry, and I want to give an equation of this line. Now, hopefully you remember from Algebra 1, the way we write the equation of a vertical line is we write x equals, and then we tell, well, the x coordinate of, well, a point that that line would go through. So I'm going to say the equation of that line is x equals -2, because every single point along this line has an x coordinate of -2. Make sure when you give the axis of symmetry, it is always an equation, not just a number, but an equation. Then, this sets up a whole bunch of what we call corresponding points, points that match up on either side of the parabola. For example, -4, 1, that point over there, matches with the point on the other side of the parabola of 0, 1. So I'm going to say negative 4 comma 1 matches with 0 comma 1. Similarly, the point negative 5 comma 6 matches with the point 1 comma 6. The same point, well, not really the same point, the point in the same location on the other side of the axis of symmetry. Notice this point is 1, 2, 3 away from the axis of symmetry. To the right, its corresponding point is 1, 2, 3 away from the axis of symmetry on the left. Finally, the vertex for this parabola is the lowest point on my parabola, which means that vertex gives me what I'm going to call a minimum. And this is going to be particularly important at the end of the unit when we start looking into word problems, trying to find a maximum profit or a minimum area or something like that. Our vertex in this case is a minimum. I'd like you to take a moment and go do your analysis of the parabola over here. Find the vertex. Give me the equation of the axis of symmetry. Give me corresponding points and tell me if the vertex is a maximum or a minimum. Take a moment and go do all of that analysis, please. Okay, so can you give me the coordinates of the vertex? Make sure you're using parentheses and a comma when you type it into Edpuzzle. What's the vertex? Well, looks like 3, comma 7 to me. What's the equation of the axis of symmetry? Draw in that axis right over there. I think the equation, make sure it's an x equals equation. If it was y equals, it would be a horizontal line. X equals 3 is that vertical line. Corresponding points. Well, let me start with 2 comma 5. What are the coordinates? Again, make sure you're using parentheses and commas of the corresponding point to 2 comma 5. I think that would be 4 comma 5. Now let's look at 1 comma negative 1, this point over there. What's the corresponding point to that one? Looks like 5 comma negative 1. And finally, is the vertex a maximum or a minimum? Here, that vertex is my highest point on the parabola. It's my maximum. Next, there are 3 different ways we can write the equation of a parabola. Hopefully you remember from Algebra 1, there were 3 different ways you could write the equation of a line. You had y equals mx plus b, ax plus by equals c, y minus y1 equals m times x minus x1, and each form was useful for different things. Similarly, there are going to be 3 important forms of a quadratic function that we're going to be looking at. And actually, this is what we're going to spend our entire first week on, going into all the details of these 3 forms. The first form, which we'll deal with today, is called vertex form. And vertex form for a parabola looks like y equals a times x minus h squared plus k. And today we'll spend time going into all the details of what exactly the a, the h, the k mean. Right now, well, let's just get this copy down. Second form is called standard form. Standard form for a parabola is y equals ax squared plus, could also be minus, I'm just going to say plus, kind of accounts for both of them, plus bx plus c. And our final form is called factored form. And factored form is y equals a times x minus p times x minus q. And this entire week, we're going to look at parabolas in these 3 different forms, talk about why each form is important, what information each form tells us, how to graph from each form. Take a moment, get that copied in your notes. And now we're going to start getting into the details of vertex form. So top of page 4. Vertex form for a quadratic function is y equals a times x minus h squared plus k. Same thing we wrote on the previous page. Just get that copied out in the box one more time. And then before we start getting into the details of the h, the k, the a, we need to look at the graph of a really simple parabola, of the parabola y equals x squared. I'm going to start by making a table of values for this parabola. I'm going to go and I'm going to plug these different numbers into my y equals x squared formula, get some points, graph that parabola, and then we'll see how the a, the h, the k are just transformations of our parabola, similar to stuff we did earlier in the year. Well, first thing, I'm going to plug -3 in, which means I get -3 squared. -3 squared is 9. Plug in -2. -2 squared is 4. -1 squared, -1 times -1 is +1. 0 squared, 0 times 0 is 0. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. Please graph those 7 points, but don't connect them yet. Okay, so -3 comma 9. -2 comma 4. -1 comma 1. 0, 0, 1, 1, 2, 4. 3, 9. I'm going to go and connect these, but I'm not going to connect them with a line. I'm not going to use a ruler or anything like that. My graph is something that's a little bit curved here. My graph is going to look, and we're just going to kind of do the best we can. It's going to look sort of something like this. And this is our basic parabola. Hopefully you remember earlier in the year when we graphed y equals the absolute value of x, that absolute value v graph. We called that graph 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, -3, 3, our parent function that we applied some transformations to. Well, now we have a new parent function that we can apply our same transformations to. Anytime there's a square in our problem, x and then maybe something else, getting squared, our parent function, oops, why has this stopped? Oh, hold on, is it still recording? I hope it's still recording. I guess I'll find out later. Sorry about that. Our parent function will just be a parabola, like what we see over here. And everything else that's going on in the formula will be different parts of some transformations. So, here's what our transformations are. These transformations will be the same that they were with our absolute value v's. If we subtract something inside our parentheses, just like if we subtracted it inside our absolute value bars, that would be a horizontal shift. Adding some number at the end, or subtracting some number at the end, that's a vertical shift. Some number out front, that's a vertical stretch. And we're going to go in that same order that we went when we did our absolute value v's. We'll first do any sort of horizontal shift, then any sort of vertical stretch, then any sort of vertical shift. Make sure that's in your notes. We're going to ignore the bottom that says Vertex. We'll fill that in a moment, but we're going to do some graphing right now. Okay, so we're going to continue on page 5 in the notes. Hopefully this is working. Okay, so we're on page 5 in the notes, and we're asked to graph 4 different parabolas, making use of transformations of that parent function we graphed on the previous page. Well, the first thing I want to do, in regular pencil, or maybe black colored pencil, or whatever, is I just want to sketch y equals x squared on all 4 of these grids. So I want points like 0, 0, 1, 1, 2, 4, 3, 9, -1, 1, -2, 4, -3, 9. And I'll connect the dots and make a nice parabola. I want to get this particular shape on all of my grids. You go take a moment and get that on all 4 grids, and then we'll start dealing with our transformations. Okay, so now I need to start dealing with some transformations, and now you're going to need colored pencils. If you don't have them, I'll make the video pause for one more moment. Go get your colored pencils, and then come back. Okay, so everything else that we see in these formulas are different transformations, just like they were with our absolute value v's earlier in the year. In letter A, this minus 4 that I see, that's my only transformation that I have. My minus 4 is not like inside parentheses or anything like that. It's a minus 4 at the end, which means I'm going to take my graph and I'm going to move it down 4 spaces. Down 4. I'm going to color code my work. Notice I did the original in dark blue, so I labeled this in dark blue. I'm going to do my down 4 in orange, so I'm labeling that in orange. And I'm just going to go and move each of my points down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Do the same over here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to go and connect the dots. And my final parabola over here looks like that orange graph. Make sure that's in your notes. Moving on to letter B. There are 2 different transformations here. There's the plus 3 and there's the plus 1. Remember the order that we have to go in. We first have any horizontal shift. Then we have any vertical stretch. And finally, I have any vertical shift. With that in mind, what am I going to have to deal with first? The plus 3 or the plus 1? I think we need to deal with our horizontal shift first, so I need to deal with the plus 3. And I'm going to go graph y equals, in parentheses, x plus 3 squared. Now, plus 3 inside our function, going back to earlier in the year, when we have a plus 3 inside, how does that move the graph? Plus 3 inside is going to move our graph left 3 spaces. So go do that. Go move your graph left 3 spaces. Should look like that. Maybe a little nicer than mine. Then we have that plus 1 that we need to deal with. Okay, well, what's that plus 1 going to do to the graph? Should move everything up 1 space. So I'm just going to take all the points, go up 1. Actually, you go take a moment and go deal with that. I think that this light blue graph that I'm doing right now should be that final graph. Oh, I just realized there was a little bit more work that we needed to do. We were asked to give the coordinates of the vertex and the equation of the axis of symmetry. Well, going back to letter A, the vertex of my final parabola, which was that orange one, vertex looks like down here. So 0, comma, -4. Axis of symmetry, that vertical line, I'm using a dashed line because it's not really part of the graph, it just kind of helps us get our graph. That vertical line is going to be x equals 0. Letter B, can you give me the coordinates of the vertex? Vertex looks like -3, comma 1. And can you give me the equation of the axis of symmetry? It's going to go through like that. I'm thinking x equals -3. Letter C. There are 3 things to deal with here. The 2 out front, the -2 inside, the -5 at the end. Which one should we deal with first? First step needs to be the horizontal shift. That's the -2 inside. So we need to go graph y equals x minus 2 in parentheses squared. Now the -2 will do what to the graph? Should move it to the right 2 spaces. Please go do that. Move your graph right 2 spaces. Hopefully looking something like that. Now what should I deal with? The 2 out front or the -5? Hopefully you said that 2 out front. Will this show up? Yeah, that's not bad. I'm going to go deal with that 2 out front. That 2 out front is a vertical stretch, which means I need to multiply my y values by 2. I need to multiply the y values by 2. We're going to do this together because it's been a little while. This point over here has a y value of 0. The new y value is 2 times 0, or 0. This point over here has a y value of 1. New y value is 2 times 1, or 2. This point has a y value of 4. My new y value is 2 times 4, or 8. This point has a y value of 9. My new y value is 2 times 9, or 18, or just way off the graph. I'm not going to bother. Do the same on the other side. 1 becomes 2. 4 becomes 8. 9 becomes off the graph. I'm going to connect the dots and get that graph. I would like you to go deal with that final step of move the thing down 5, and then tell me the coordinates of the vertex and the axis of symmetry. This light purple one should be that final graph. Vertex is, let's see, I'm thinking 2, -5. Axis of symmetry is, I hope you didn't say 2, I hope you said x equals 2, that vertical line right over there. D is as difficult as they're going to get. Please go do your first step of D. Okay, first step is the horizontal shift. That's the +4. Y equals, in parentheses, x plus 4 squared means I'm going to go left 4. Now, the -1/2. First of all, with a 1/2 up front, so I'm going to stretch it by a factor of 1/2. Is that going to make it wider, or is that going to make it narrower? Should end up making it a little wider than before. But the negative, what's the negative going to do to it? That negative is going to end up flipping it over the x-axis. We're going to do this part together. I'm going to multiply my y values by -1/2. This y value is 0. Negative a half times 0, still 0. This y value is 1. 1 times negative a half is negative a half, or negative 0.5. Do the same over there. This y value was 4. My new y value is negative 1/2 times 4, which is negative 2. This y value is 9. My new y value is negative a half times 9, negative 9/2, or negative 4.5. I'm going to connect the dots. And it looks like that. Please do the final transformation and then figure out the vertex and axis of symmetry. Let's see, this is at negative a half, so halfway between 2 points here is 1, there 2, there 3, so it's going to move up like that. This one was right at negative 2, go up 3, it's 1, 2, 3, like that. This one was again halfway between 2 points, that's okay, we can still move it up 3, 1, 2, 3, like that, and like that. I'm going to connect the dots. And there we go. Vertex. Looks like negative 4, comma 3. Axis of symmetry. Vertical line through that vertex. X equals negative 4. This is about as difficult as the graphing is going to get. Now, before we move on, there's one thing I want to fill in on the previous page. In letter D, my vertex was negative 4, comma 3. In C, it was 2, comma negative 5. In B, it was negative 3, comma 1. Do you see those numbers showing up somewhere in the problem? And if so, where? My vertex can be seen basically as looking at the opposite of this number, comma this number over here. Plus 3, negative 1, my vertex is negative 3, comma 1. Over here, minus 2, minus 5, positive 2, negative 5. Over here, negative 4, positive 3. My vertex shows up in the problem because really the vertex just kind of tells me things about how I was moving my original parent function to the left and to the right, to the left or to the right, or up or down. This parabola was moved left 4 and up 3. So my vertex is negative 4, comma 3. This parabola was moved right 2, down 5. So my vertex is right 2, 2, down 5, negative 5. Going back to that previous page in the notes, if I give you a parabola in the form y equals a times x minus h squared plus k, my vertex is just the point h, comma k, which we can think about as how did I move my graph horizontally, comma, how did I move my graph vertically. We'll do a little bit more work with that in a moment, but make sure you get that in your notes on page 4. Okay, next thing we're going to do is we're going to take a look at page 6. The effects of that a value. And before we do this, I would like you to take a moment and look at the Desmos activity that Edpuzzle is going to link you to. So hopefully you already saw through that Desmos activity that if our a value is positive, the parabola opens up. Will look something like that. And if the a value, that number out front, is negative, the parabola opens down. Something like that. Then you saw that if we ignore the positive negative parts, just look at the absolute value of the number out front, which really means ignore the positive and negative thing. The bigger that number, the narrower our parabola will be. So y equals 3x squared is narrower than y equals 2x squared. Y equals 3x squared is also narrower than y equals negative 2x squared. The bigger ignore the sign, absolute value of that number, the narrower the parabola. So, let's see what you can do over here. First of all, I would like you to circle the parabolas that open down, and then order them from widest to narrowest. See what you can do. Okay, well, the ones that have a negative a value are opening down, so that's going to open down, and that's going to open down. Widest to narrowest. So I guess so ignore the signs. I'm looking at 4, I'm looking at a half, I'm looking at 1/7, I'm looking at 7. The bigger that number, the narrower the parabola. So the smaller that number, the wider the parabola. I think this one is my widest parabola. Y equals negative 1/7 x squared, that's the widest. Followed by, I think the next smallest number is 1/2. Y equals 1/2 x squared is the next widest. Then 4 and 7, 7's the biggest, so that's going to be the narrowest. So we're going to go with y equals negative 4x squared next, and then y equals 7x squared. Ignoring the signs, our numbers go in order 1/7, then a half, then 4, then 7. You're going to use those ideas of wide, narrow, up, down, and all that stuff to match these 3 formulas with these 5 graphs. I'd like to see what you can do with those. Okay, well, I know that 1 and 2 have got to be D and E because those are the 2 that are negative. Those are the 2 that are opening down. Ignoring the sign, I've got 3, I've got a half. The bigger the number, the narrower the parabola. So 1 has got to be E. And 2 has got to be D. The other 3 all open up. Again, the bigger the number, the narrower the parabola. I think my narrowest parabola is letter C over here. I'm going to go with 3 and C because 4 is the biggest number I have out front. Followed by 5, that just has a 1 out front, so I think that should be B. Followed by 4, that has a 1/2 out front. One last thing we're going to take a look at in this section. We now know how to graph parabolas. We now know how to analyze them a little bit. The last thing we need to be able to do, which is on page 7 in the notes, is create the formula for our parabola. Now, when we did this with absolute value v's, we just kind of looked at the graph and got our answer. Not going to be true here. We're going to have to go through a little bit of algebra here to get our answer. Letter A, I want the equation of the parabola in vertex form with the given vertex going through the given point. Okay, I want this parabola. Well, if it's in vertex form, I know that it needs to be in the form y equals a times x minus h squared plus k. We know that the h and the k are the vertex. Those are the coordinates of my vertex. I know the vertex of my parabola is 3, 1. So I'm just going to fill those numbers in for h and k. I'm going to get y equals a, don't know the a yet, times x minus 3 squared plus 1. By the way, checking this with transformation ideas, we know a minus 3 inside would go to the right 3, a plus 1 would go up 1. Yep, looks like right 3 up 1 is looking good. Then, to figure out our a value, I gave you an additional extra point on the parabola. What I can do is I can plug in that point for x and y and go through some algebra to solve to get the a value. I'm now going to plug in the other point. in this case, looks like positive 1 comma 0 for x and y. And we're going to solve the equation we get, of course showing all of our algebra, to get a. I'm going to plug in the other point. I'm going to plug in the 1 comma 0 for x and y, and I'm going to solve to get a. Get that copied down. So this is going to look like 1. No, it's not, sorry. It's going to look like, I'm going to plug in 0 for y. I'm going to plug in 1 for x. 0 equals a times 1 minus 3 squared plus 1. Okay, well, I'm going to work through the calculations here. 1 minus 3 is negative 2. Negative 2 squared is 4. So I'm going to get 0 equals 4a plus 1. Minus 1 minus 1. Negative 1 equals 4a. Divide, divide. My a value is negative 1/4. And I now have all the information I need to be able to write the formula for my parabola. I basically had it over here. I just needed that a value, which I just calculated. And my final answer is going to be y equals negative 1/4 times x minus 3 squared plus 1. What we're doing is we're filling in our vertex for h and k. Then I need to go through some algebra to find the a value. So I'm going to fill in that other point for x and y, solve my equation for a, and then write the formula. In letter B, my formula is y equals a times x minus h squared plus k. Okay, what are you going to fill in for h and k? Negative 2 comma negative 3 or negative 3 comma 0? I think we need our vertex. My vertex in this problem is negative 2 comma negative 3. So I'm going to say y equals a times x minus negative 2 squared minus 3, or really y equals a times x plus 2 squared minus 3. I know this is right because I know this means I should go left 2 down 3, left 2 down 3. Yeah, that's all check. Then we have our other point. We have that negative 3 comma 0. You take a moment, plug in negative 3 for x, 0 for y, show all your algebra, find the a value. Tell me what the a value ends up being. I'm getting a equals 3. So my parabola is going to be y equals 3 times x plus 2 squared minus 3. I need to see all of this algebra when you're going to do these problems. Final thing in the notes. In C and D, I did not give you graphs, I just gave you information. Well, it's going to work the exact same way. Letter C, my parabola is y equals a times x minus h squared plus k. My h and k are just the coordinates of the vertex. Here's my vertex, 3 comma 4. H is 3, k is 4. My parabola is y equals a times x, move right 3, move up 4. To find the a, we're just going to plug 5 in for x. We're going to plug negative 4 in for y, and we're going to solve to get the a. We're going to get negative 4 equals a times 5 minus 3 squared plus 4. You go finish that and tell me the a value. Negative 4 equals a times 2 squared plus 4. 2 squared is 4, so negative 4 equals 4a plus 4 minus 4 minus 4. Negative 8 equals 4a. Divide, divide. A should be negative 2, And my parabola is y equals negative 2 times x minus 3 squared plus 4. If you go to graph this parabola, start from your parent function, go right 3, multiply the y values by negative 2, then go up 4, that parabola would have a vertex at 3, 4, and it would end up going through the point 5, negative 4. Try D, and then we'll be all set. Vertex, so that's the h, that's the k. I'm going to get y equals a times x minus negative 1. I'm just going to say x plus 1 squared plus 0. I want my parabola moved left 1, not up or down, to get to negative 1, 0. Yeah, that works. 2 equals a times negative 2 plus 1 squared. 2 equals a times negative 1 squared. Oh, this isn't bad. A is 2. Y equals 2 times x plus 1 squared. I'm pretty sure in the homework a lot of the a values end up being fractions. Whatever, it's fine, just leave it as a fraction and take that as your a value. So this is our first of 3 forms of the formula for a parabola. Over the rest of the week, we will deal with the other 2 forms and see how to work with those.